In this video we're going to look at transposing formulae. Formulae is plural for formula, and the way that questions are written here is you're given the formula and then in brackets or something like that, that's the pronumeral that you make the subject of the formula. So here we've got to make R the subject, so we have to end up with R equals. So in this case we've got I times R. The opposite of timesing by I is dividing by I. So I'm going to divide both sides by I. So the I's cancel out and we end up with R equals V over I. In this question we have H equals I over 2 pi d. We have to make d the subject, but unfortunately d is in the denominator and we really need it in the numerator. So what I'm going to do this time is I'm going to times both sides by 2 pi d. So it just appears off that side and reappears on this side. So this is going to be 2 pi dh is equal to I. And then I'm going to look at this left hand side and say basically what's happening here, d has been multiplied by 2 pi h. And then I say what's the opposite to that? And it will be dividing by 2 pi h. So you can see that. Okay, so that means that d is equal to, now that's not very nicely written, is it? So it's I divided by 2 pi h. Now two more formula to transpose. This time we want to make I the subject. Here we've got I squared. So I squared, basically I has been squared and then it was times by RT. So what we need to do is divide both sides by RT. So that means that I squared is equal to E over RT. And then you think, how can I get I squared to I? And you take the square root. What you do to one side, you do to the other. So the opposite of squaring is taking the square root. So if you take the square root of both sides, you end up with I is equal to the square root of E over RT. In this question, a fair bit more difficult because there's a few things involved. L is the pronoun we want to make the subject. L has been times by C. The square root's been taken and then that was times by 2 pi. The biggest problem we've got is that it's in the denominator and we need it in a numerator. So I'm going to multiply both sides by 2 pi square root LC multiplied by 2 pi square root LC. So that means 2 pi f square root LC. Now I was very careful to write that way so that it didn't look by mistake as if f was included in the square root, is equal to 1. So in the quest to make L the subject, we need to get rid of this bit here. So that's timesing by the square root sign, so we need to divide both sides by 2 pi f. So the square root of LC is equal to 1 over 2 pi f. Now we need to undo the square root. The opposite of square root is squaring, so we need to square both sides, so that's LC. And 1 squared will be still 1 over, let me put that in, squaring both sides, so that will be 4 pi squared f squared. Now we've got LC, we wanted to make L the subject, we need to get rid of the C. L's been times by C. The opposite of timesing by C is dividing. So we're going to divide both sides by C. So that means that L is equal to 1 divided by 4 pi squared F squared C. Now, I put in question 3a because it's a fairly unique type of question. If you see one, the way to deal with it is usually pretty standard. We need to make R the subject, but at the moment 1 on R is the subject. So what we need to do is need to think about what we would do if we were adding fractions. When you add fractions, you go to a common denominator. And if you don't exactly know what the denominators are, like their pronumerals, the new denominator will be the product of those denominators. So it will be R1, R2. And on the top we'll get R2 plus R1. Okay, so when you add fractions, the new denominator is usually made up of multiplying the old one, and then you've got this effect. That times that and that times that gives those two top terms. Now we can take the reciprocal of both sides and the question's solved because we've made R the subject. Now the next one's going to be a challenge. We have to make R the subject, and R here's been cubed. It's been divided by GM. The square root was taken, then it was times by 2 pi. So 2 pi's got to go first, and we're going to divide both sides by 2 pi. So t divided by 2 pi, 2 pi is going to disappear, is the square root of R cubed over GM. So now we think, what's the opposite of square root? It's squaring, so we'll square both sides. So t squared on 2 squared is 4, pi squared is equal to R cubed over G. I was about to do a lowercase g over GM. Now, R cubed has been divided by GM. I'm going to multiply both sides by GM. So GM t squared on 4 pi squared is equal to R cubed. And then we think, how do we get R? What's the opposite to cubing a number? It's taking the cube root of both sides. So the cube root of R cubed is simply R. And I'm going to have to write this out here, is the cube root of GMT squared over 4 pi squared.